Hello, my name is Mr. Asprey and I've had a couple of requests to do another IGCSE speedrun. I really enjoy doing them, so I'm going to give it a go. I'm going to try and get 100% in under 30 minutes. It's going to be tough, but I'm going to give it a go. And if you are looking for a grade 9, then check out my live revision session, link in the description. I'm going to be going over loads of grade 9 type questions in that session. It should be a lot of fun, so check that out. And I've also had quite a few requests for me to do something for paper 1, which is on the 15th of May, I believe. I'm not quite sure if I'm going to have time to do that, but I'll leave a comment in the comments. And if that gets, say, like 100 likes, then I will put something together for paper 1. Okay, so subscribe, check out my live revision sessions, and comment below. Okay, so here are all the papers that are available, and the ones in green are the ones that I have already done on my channel, so I won't be doing those again, but we will ask Siri for a random number. Siri, can you give me a random number between 1 and 46, please?
It's 39.
39, fine and dandy. Okay, so 39 is this one right here. So that is Jan 23 1HR. Okay, I will just go find that paper. Okay, here it is. Yeah, this is the paper. It's 1HR, it's Jan 2023. And I'm not going to look at the question to start with, but I wanted to read this because the last one I did had 26 questions and it really threw me. So this one has 24. Okay, fine. So just need to find out where the clock is. Okay. Okay, should be good to go. Let's do it. Oops. Okay, so oh gosh, write down the modal class. That's the one with the most frequency. So that is 48 to 54. Work out an estimate for the mean frame size. Okay, so I'm going to do this quickly. We're going to go midpoint times frequency plus midpoint times frequency plus midpoint times frequency plus midpoint times frequency and then plus midpoint times frequency. I'm going to write that answer down because I do want method marks just in case I make a mistake. And we're going to divide that by the total frequency, and luckily it tells us that it's 60, so we don't need to add it up. So we're just going to divide that by 60. Brilliant. And it wants it. It doesn't say how accurate, which is helpful because it means that it's going to be a nice number. Okay, next one. The total surface area. Okay, so for the triangle, it will be 1/2 times base times height, of which there are 2 of those triangles. So that will just be 3.6 times 4.8. Okay, so that is 17.28. And then all of the other sides all have a length of 7. And one has a side length of 6, the other has a side length of 4.8, and the other has a side length of 3.6. So just to save time, I'm just going to add them all up like that. So it's 7 lots of, and again just using factorising here, because they all have a side length of 7. So just need to add their widths to get the widths together, and then times it all by 7. Okay, so let's add those together. And then we should be good, 17.28, and that gives us 118.08. So to 3 significant figures, that's 118. Brilliant. Okay, I forgot how intense this is. A range of 9. Okay, so that must be 3, so that the gap between the biggest and the smallest is 9. A median of 8. which means that, not quite sure, but a mode of 10 means that Z must be 10, so that 10 is the most common number. So a median of 8 means that must be 6, so the two middle average out to 8. So I think that's done. So X is 3, Y is 6, and Z is 10. Cracking. Okay, pays the same amount as the amount that Wan pays. Work out the value of K. Okay, so they both pay the same amount. So 16% means you're timesing by 0.84 if you're taking 16% off. So let's just do that calculation. Okay, so that's how much the Divia's holiday is. Now Wan has a special price, a certain amount off. So we know that 1400 was multiplied by some multiplier, let's call it Y, and then that gave us the same price that Divia is paying. So we need to just do this divided by that. And we get 0.96, which means that must be a 4% decrease. So K is equal to 4. Okay. Grams of chocolate is shared. Okay, the difference between the largest and the smallest is that. So the difference between the largest and the smallest is 6 shares. So 6 shares is equal to 390. So 1 share is equal to 390 divided by 6. Which is equal to 65. Okay, work out the value of C. C, grams of chocolate, is shared. Okay, so just the total. So the total number of shares is 15. So 15 times 65 is going to give us 975. Okay, simultaneous equations. Fine. Let's times the top one by 3, and that's going to line up the y's. And then let's add them together. It's going to cancel the y's, so you get 7x is equal to 49, so x is equal to 7. Let's sub into the top one. We have 7 plus 2y is equal to 15, so 2y is equal to 8, so y is equal to 4. So y is 4, x is 7. Okay, when we're doing standard form, we can literally just count the number of zeros when we're doing a small number. So there are 5 zeros, so 1, 2, 3, 4, 5. Yeah, that works. Okay, so work this out. Give your answer in standard form. Okay, so that is 300,000, and then we're minusing 60,000, which will give you 240,000, which is 2.4 times 10 to the power of 5. Work out this. So 3 times 6 is 18, and then add the powers of 10. 55 plus 65 is 120. So I need to divide this side by 10, which means I need to add a power of 10 on here to balance that out. So that's my final answer. Okay, factorise fully. So we can take out a factor of 3, and we could take out a c squared. So that's 6c d squared minus 7. I think that's right. Yep. Okay, so y minus 6 y plus 3 will do the job there, I believe. So therefore y is equal to 6, or y is equal to minus 3. Okay, an isosceles triangle. The area of the triangle is 40. Okay. Work out the value of y. Just slightly hesitating here, which is a bit annoying. So the height. Okay, so of course it's half base times height will equal 42. So 7h will equal, times both sides by 2 is 84. So h is equal to 12. And then we've got 3.5 there, and the height is 12, so we can use Pythagoras to find y. So it's the square root of 3.5 squared plus 12 squared. Okay, so we need to do square root of 3.5 squared plus 12 squared. It doesn't ask us to round, so I'm hoping this is going to come out as a nice number. Perfect. So 12.5 is my final answer there. Okay, work out the area of this triangle. So we know from circle theorems that's right angle because, or do we? Oh, M is the midpoint, yes, it's perpendicular bisector, always goes through the centre, so that is definitely the midpoint. RT is 12, so that is 6, so I'm just looking at that triangle on the left. So we can use trig here to find the radius r, because we know that sine of 52 is equal to the opposite over the hypotenuse. So r is equal to 6 over sine 52. Okay, so let's do that. I'm in radian mode. I should not. That is sloppy. I should have not done that. Okay, so 6 over sine 52, and that's going to give us 7.61. And then the area of the triangle, of course, is equal to pi r squared, which is going to be pi times 7.61 squared. So I'm just going to square that and then times it by pi. And that is going to give me 182.1, which is approximately 182 to 3 significant figures. Okay, cumulative frequency. Okay, so we just need to add up. So 7 add 10 is 17, add 15 is 32, add 32 is 64, and add 16 is 80. Always double check. Yes, look, there are 80 patients. That's good. Draw on the opposite grid. Oh, this is annoying. This is going to cost me some time here. I'm just going to plonk that over there. And then... it's costing me time. No. Okay. So 10 is 7, which is going to go there. 20 is 17, which is going to go there. 30 is 32, which will go there. 40 is 64, which will go there. And 50 is 80, which will go right at the top. We then connect it up. You could do a curve, but you can also just do a straight lines. So I'm now a straight line guy after being a long advocate for curves. Anyway, use your graph to find the estimate for the median. It does say use your graph, so I'm definitely going to have to draw that line on there and then draw the line down. And this is where doing it on a computer really is going to slow me down. But that to me looks like about 33. We're going to go 33. Interquartile range. Okay, so 3/4 of the way it will be the 60th position. So come all the way down there. That to me looks like 39. And then 1/4 of the way is the lower quartile. So that come down there. That to me looks like 22. So 1 minus the other is 17. So we're going to go with that. And we're going to get our zoom back. And we're going to go down. And we're going to need to catch up some speed here because we've messed up too much time. Anyway, okay, that's quite tricky, but I know that 2 to the 5 is equal to 32, so therefore that's basically just saying minus 4x is equal to 5, so x is equal to 5 over minus 4, which is just minus 5 over 4. Got to use algebra to show here, so what we're going to do is x is equal to 0.381 reoccurring. I could just times through by 100 because there's 2 things reoccurring to get 38.181 reoccurring, and then we can subtract. And we'll get 99x is equal to, so these will cancel, and then we just need to do 38.1 minus 0.3, which gives us 37.8, and then we could divide through by 99. And then we could times top and bottom by 5, which will cancel out and make that a whole number. So that's that, and then times 99 by 5 gives us this. And then I guess we could just to the calculator. So 189. I don't think you need to show divided by 495, and that does equal 21 over 55, so we've got that right. Okay, we are looking for the upper bound of t. So t upper is equal to p upper over r lower. P upper will be 0.515 and r lower will be 6.25. So I think that is all we need to do. 515, and that is then over 6.25, and that is equal to 0.08. Once again, they don't ask you to round, so that gives me maybe feel like I got that right now. Okay, fine. Should I just do table function? I think so. Let's just do it. Why not? X cubed minus 3. I'm not sure if this is the quickest way, but we're in it now, so let's just go with it. We're going to start at minus 2. We're going to end at 2, and we need to go up in 0.5s. So the one I'm looking for is minus 2, which is 0. I'm looking for, whoopsie, all over the place. Steady. I'm looking for 0 is 2. Oh, I really should have just done this in my head. And 2 is 4. Definitely should have done that in my head. Sloppy. Okay. Zoom out and plot. Minus 2 is 0. Minus 1 is 4. Minus 0.5 is 3.4. 0 is 2. 1 is 0. 1.5 is 0.9. And 2 is 4. Okay, and it wants us to just go from there to there, so we're just going to plot it out just a curve like this. It's going to curve round, it's going to come down. Again, you have to give me the benefit of the doubt here because I can't really trace it very well, but I think that's good. That's all good. That is good. Yes. Oh, these questions. By drawing a suitable line on the grid, use your graph to estimate the solution for that. Okay, so what is the graph? It is x cubed minus 3x plus 2. So the graph we have is x cubed minus 3x plus 2. So we want to manipulate this to make that on one side of the equation. So the first thing I'm going to do is going to divide this equation by 2, like this. And then all I need to do is I just need to subtract 1.5x to both sides. And that will give me x cubed minus 3x plus 2 equals 0. And I've got my graph on that side. No, not equal to 0. Silly, silly. Minus 5x. Yeah, so I've got that one on the left plotted. I just need to plot this one on the right. Minus 1.5x needs to be plotted. So that goes for the origin because there's no intercept. So every one you go along, you go down 1.5. So go back in reverse, you go up 1.5. So it should look like this. So we'll draw that on with a nice straight line. And that is it. So the question is, find the solution, singular, and answer, singular, which gives me good reason to believe I've got this right, because there's only one answer. And that one is minus 1.6. You can use your calculator to give you a check to see if you got that right, but I haven't got the time. Okay, right, let's get my zoom back. And we are finding the function f of x a third, so that's 2 over 3 times a third minus 5, which is 2 over 1 minus 5, which is 2 over minus 4, which is minus a half. Yeah. Find the inverse function. Well, we set it equal to y. Swap the x's for the y's, and the y's for the x's, and then rearrange again to make y the subject. So multiply through by the denominator, expand out that bracket, move all the non-y terms to one side, and then divide through to get y like that. So therefore the inverse function is equal to this. Okay, so just factorize that. No, complete the square, sorry. So 5 goes outside the bracket. We leave x squared in and minus 4x. 23 could stay outside. And then if I complete that square, we half the b term and then minus that halved b term squared, like so. So this gives us 5 lots of. This here is minus 2 squared, which is 4, and then it's a minus 4 times by 5 is minus 20, and then plus 23, so it's going to be 5x minus 2 all squared, and then plus 3. Okay, we've got area of a triangle again. This time it's 12. Work out the perimeter of the triangle. Right. This angle here is acute. Okay, perfect. So we can find that angle because we know a half AB sine of the angle is equal to 12. So it's a half, and AB have to be the two sides which are adjacent or next to the angle. So it's this, and we know that's equal to 12. So let's reverse engineer this, and let's say that 12, let's times it by 2 to get rid of the half, divide it by 8.3, and then divide it by 4.6, and that will give us sine theta. And then we can take the inverse sine, checking we're in degree mode, of that, so we get that theta is equal to 38.9. Now we've got to do the cosine rule. So let's call this little a. So a squared is equal to b squared plus c squared. So those are the two sides opposite, adjacent to the angle again. Minus 2 times b times c times by cosine of the angle 38.9. Okay, so let's put that straight into the calculator. So square root first, and then 8.3 squared plus 4.6 squared minus 2 times 8.3 times 4.6 times cosine of 38.9, close brackets. Okay, sounds reasonable. 5.53. So the perimeter is equal to 5.53 plus 8.3 plus 4.6. So we just need to add on 8.3 and 4.6, and we get 18.4 to 3 significant figures. Okay, solve given your answer as a surd. Okay. Oh, tricky. Right, let's multiply out. So root 3x minus root 3 times root 3 is 3 times minus 2 makes minus 6, and that's equal to x plus 2 root 3. Let's move all the x terms to one side. So minus the x, and then move the other term over. So that goes there, that goes there. So add 6 on. So it's 2 root 3 plus 6. We can then factorize over here, take out an x, which gives us root 3 minus 1, and that equals this, and then we can divide through like so, like this, but we need to rationalize this, so we've got to times it top and bottom by the denominator, but with the sign changed. So doing the top, that times that is going to be 6. And then plus 2 root 3, and then 6 times root 3 is 6 root 3, and then 6 times 1 is 6. And that's all over the bottom, which will be root 3 times root 3, which is 3. The other ones in the middle will cancel out, and then you get minus 1 times 1 is minus 1. So we have 12 plus 8 root 3 over 2, which leaves a grand total of 6 plus 4 root 3. And just double check if that's what they want it in. Yes, perfect. Right, P is inversely proportional to y squared. So P is equal to K over y squared. When P is A, y is 4. So that gives me 16, so I have to square it. Okay, so we now know that 16a is equal to k. So we now know that P is equal to 16a over y squared. Okay, it is also given that y is directly proportional to, so y is equal to k times by, because it's directly proportional, root x. Now k is not the same k, just to be clear, so we need to work out a new k. Okay, so when x is, right, oh gosh, this is a bit tricky, isn't it? Fine, let's then sub that in, so we get P is equal to 16a over y squared, and we know that y squared is equal to k squared x by squaring this one here. So that's k squared x, like that. And now that is a, oh no, I've got a knock at the door. Unbelievable. Right, I need to pause it, I'll be back. Okay, I'm back. Kitchen roll sorted for the next 3 months. Okay, where were we? We were saying that P is equal to this, and we subbed that in. And now we've got P in terms of X, so we should be able to use this to find K, and then that will be the formula that we need. Okay, so 16a over K squared X, which is just A. Oh no. Well, this is after I've subbed. This line doesn't make sense because we need to put it here, and that's when I've subbed in P, which is 4a. So sub in put P 4a and sub in for X A, and then we're good. Okay, so this is 4a is equal to, these a's can cancel, so 16 over x squared. Rearranging gives us, sorry, k squared. So k squared is equal to 16 over 4a. So k is in fact equal to, when I square root this, it's 4 over 2 root a, which is the same as 2 over root a. So that's what k is. So now we can say that P is equal to, and in fact k squared then, because we're going to need to use k squared, is 4 over a. So using this, P, we've got 16a over k squared, which is 4 over a, times by x. Now we can multiply the a, we can multiply top and bottom of that fraction by a to get 16a squared. It will cancel the a on the bottom there, so 4x. Wowza, what a tricky question. I might have to do that as a standalone video, that one. Okay, here is a sketch of cos bloody blah, given that find the value of a and b. Okay, right, so that comes in like this, which goes in like that, which goes in like that. That's what the cos graph looks like. Now you can see that it's been stretched up by a scale factor of 2, so a is 2, and then how far has it moved over? Well, let's look at this here, the minimum point. The cos graph needs to move. How far is that? That is 135. Yeah, because that's 45 there, so it's 135 to the left, which means you need to add on 135. So B is 135. I think that's right, though I would like to check that a bit more. Anyway, haven't got the time. Work out the angle that BE makes with the plane. Okay, so BE comes in like that, and then we're going to draw a line directly down, and then we're going to draw a line across, and we're going to need to work out this angle in here. So what we could do is use this triangle on the side that has an angle of 18 and 2.2 here to work out this slide length here, dA. So we can say that tan of 18 is equal to the opposite over dA. So dA is equal to, we can solve this by going to our calculator and doing 2.2 over tan of 18, close bracket, equals, so that's 6.77. So this one down the bottom, dB, is going to be a Pythagoras, where that is the hypotenuse, and we've got 6.77 there, and we've got 6 there. It's a really ropey looking right angle triangle. Anyway, we're going to take that 6.77, square it, plus 6 squared, and that's going to give us 9.05, and then finally we could do a tan theta of the blue triangle, the 3D one which I drew, which is the opposite, 2.2 over the 9.05. So tan is equal to the inverse of 2.2 over that value, which gives us 13 point, to one decimal place, 7. Okay, oh no, you're kidding. Oh no. No chance of getting under 30 minutes now. M is the point OB such that OM is, okay, so that is, right, that's 4/5 of the way along, that's 1/5 of the way along, that's what that's saying. AN is this part, so that's 3/5, and then NB is 2/5, like that. OA is 5 to 3, so no, yeah, so that's 5 out of 8, and this is 3 out of 8. Yeah, I guess that's right. Okay. Find an expression for ON. Oh, okay, so OA is A. Alright, so that is A the whole way. And OB is B. Okay, so at least that's 4/5 B and that's 1/5 B. But if that's A and that's 5/8 of the whole thing, then that means that this part here will be, why am I struggling with this? If that is A, then this part here, we would need to divide it by 5 and then times it through by 8. So this will be 8/5 of A. The whole way along would be 8/5 of A, but we just want that tiny bit, so that will be 3/5 of A. Okay, so this is 3/5 of A, and that whole thing there is A. Yes, we divide it by 5 and then we times it by 3 is another way of just thinking about it. Apologies that took so long. Okay, find an expression for ON. Okay, so first off, what we're going to need to do is find an expression for B to A. Because B to A is minus B plus A. So B to N is 2/5 of that. So O to N is equal to, we need to go up here and then down here. So going up to B is just 1B, and then we need to add on Bn, which is 2/5 minus B plus A. It has to be in its simplest form, so we need to expand this out. 2/5, let's just do 0.4, it may be easier. So minus 0.4b and then plus 0.4a. So overall we get 0.6b plus 0.4a. Oh, that's only part A. Oh no. Use a vector method to show that MNE is a straight line. Okay, fine. This one here. So what we need is we just need two vectors that are on that line. So let's just go with ME, because maybe this is the easiest one. So ME would be just simply going down and then across like that. So that will be minus 4/5 b, which we'll write as just minus 0.8. And then add both of these together is 8/5 a, which we will write as 1.6 a. Okay, and now let's just do mn. So m to n, that will be 1/5 b and then bn. So it is 1/5 b, which is 0.2 b, plus bn, which is this, which is minus 0.4 a plus 0 b plus 0.4 a. So that'll be minus 0.4 b and then plus 0.4 a, which gives in total minus 0.2 b plus 0.4 a. Okay, so that's not particularly neat, but we can see here clearly that this guy is exactly 4 times this guy, and that is what's going to prove it for us. So I'm going to say that ME is equal to 4 times MN. And as they both share M and are multiples of one another, we have a straight line. We have that MNE is straight line. So always good to write a little conclusory statement as well. And that is job done. Horrible question that. Okay, G passes through the curve where the gradient is 10. G is on the point of where and then the straight line Q passes through G and is perpendicular to the tangent at G. Find an equation for Q. Okay, so first off, what we're going to do is we're going to do dy by dx of this curve, which is going to give us 16x minus 14. And then we're going to set that equal to 10 because it says the gradient is 10 at this particular point. So we get this, and then we get 24 over 16, which is the same as 3 over 2. So we know the x-coordinate of G. Q, the straight line passes through the point G and is perpendicular to the tangent at G. Okay, so the tangent at G has a gradient of 10. So the perpendicular at G has a gradient of the negative reciprocal. So the gradient is minus 1 over 10. And we also know the x-coordinate is 3 over 2. We just don't know the y-coordinate, but we can find the y-coordinate of G by subbing into the line which we know it's on, which is this line as well. So if we sub in this, like so, then minus 14 times, then this is going to give us minus 9. Okay, so y is equal to minus 9. So we have this coordinate and we have a gradient, so we can work out this. Y is equal to mx plus c. Minus 9 is equal to minus 1/10 times by the x-coordinate, which is 3 over 2, plus c. So we can find c by doing minus 9. When I move that to the other side, it will be plus 1/10 times 3 over 2, which is 1.5. Oh gosh, okay, not ideal. But we get y is equal to minus 1/10 x minus 177 over 20. We're going to times through by 20 to get 20y is equal to minus 2x minus 177. And then we're going to write it all equal to 0. So we're going to move it all over to one side and write it like so. And I hope that is right. Final question. Yay! An arithmetic sequence has first term 8 and common difference 11. The sequence has k terms. The sum of the last 20 terms of the sequence is this. Find the value of k. Oh, that's quite tricky, isn't it? Okay, it's the sum of the last 20 terms of the sequence. That's a thinker. Okay, so if it has k terms, then if I add up all k terms from the first term to the k term, and then if I look here and I do another sum from the first all the way up to the k minus 20th term, then would that leave me the last 20 terms? Well, the next one would be k minus 19. And then from there we would have all the way up to k. So that would work, yes. That would give me all of the 20th terms. So I need to then do a summation up to k and then subtract the summation up to k minus 20. And that should be the last 20 terms, the green part. So the summation up to k will be k over 2, just using the formula that we know. 2 lots of a is 16, plus, n, which is k, minus 1 times by d, which is 11. And then we're minusing the second summation, which is k minus 20 over 2, up, starting again at 16, at 8, so 2 times that is 16. And then we're plussing k minus 20 minus 1 times by d. And all of that should equal this 10170. Wow, that's tough. If this, I really hope this is right. Otherwise, I'm going to look very, very silly. Let's times through by 2 to cancel off all those divide by 2s. So that gets rid of this guy and this guy, essentially. Now we can multiply out. We get 16k. We get that times that, which is plus 11k squared. And then we get k times minus 1 times by 11 is just minus 11k. And then we're going to be taking away k minus 20 needs to be multiplied by everything in this square bracket. So let me just simplify this square bracket. We're going to have 11k minus 21 is going to be times by 11. And then we need to add on 16. And we get this minus that. Oh my gosh, what? Oh my gosh, what a question. I really hope this is right. Okay, so then plus 5k, because that will cancel. And then we just need to expand this quadratic, this double bracket really. So we're going to get 11k squared. We're going to get minus 215k. We're going to get minus 220k. And we're going to get plus 20 times 215, which is this. Okay. Oh wow, look at that. The 11k squareds, they will cancel out because of the minus sign there. So we just have 5k. In that bracket we have 435. Okay, so minus 435. But then there's another minus here. So that is going to give us a total of plus 435k. And then we're going to get minus 4,300. Okay, so let's take 20340 and add on the 4300. Okay. Oh, oh, this is not going to be a whole number, is it? Oh, please. It has to be a whole number, please. Please be a whole number. I do not want to have to go back and check. Please be a whole number. Yeah! Let's go. Okay, bosh, we're done. We're done. What's the time? 42 minutes-ish. I can't quite see the clock right now. Wow, that is that. I guess that's slow, really. I don't know. Maybe 30 was way too optimistic. Came up with a couple of stinkers there, though. That was stinky. And there was another one in there that was stinky as well. But hopefully we'll get 100%. And I will go and check now. Hello, and yes, got 100%. So very pleased with that. Obviously the time wasn't as I was hoping, but happy not to make a mistake. And makes the marking process much easier. There's two little tiny bits to talk about. In that I just gave like an equivalent answer. So the first one was for the cumulative frequency. Apparently the exact correct answer was 16, but you're always allowed some leeway as long as you've got your lines drawn nicely on the graph, which I have just about. Don't look at that. That was just me rushing. I think I'll get away with that. You allow it. And then the other one was all the way at the bottom. I know it was the really tricky one, this really tricky question, which threw me when my Amazon delivery came halfway between it. It is correct, but I just didn't simplify at the end. It doesn't say you have to simplify. So the simplified version would be, I would just need to divide through top and bottom by 4. To get 4a squared over x. So that would be the nicest of answers, but any equivalent answer was correct. Check the mark scheme and it's all good. Alright, I hope you enjoyed that. Check out my live sessions. Comment below if you want me to do anything for paper 1 this year, and I'll see you in the next one. Bye for now.